So our last topic in this section is about standard unit vectors. So let's define what those are. So the definition of a standard unit vector, they're two very special vectors that happen to be unit vectors. The unit vectors, so 1, 0 and 0, 1 are called the standard unit vectors in the plane. And the way we notate these, we use an I for the first vector, 1, 0, and we use a J for the second vector, 0, 1. And what's nice about these standard unit vectors is I can use them when I write any vector. So let's take an arbitrary vector v, v1, v2. You can split it up as the sum of the vectors v1, 0 plus 0, v2. And this is the same thing as the scalar multiple v1, 0 plus v2, 0, 1. And if you look, you'll notice that these vectors right here, this is I and this is j. So I can write my vector v as v1, I, and v2, j. So sometimes these scalars then, you might hear this one called the horizontal component, and then this v2 would be called the vertical component. So let's look at an example. Let's say U is a vector with initial point to -5 and terminal point -1, 3. Let's write the vector v as it's going to be 2i minus j. Right? Each vector has a linear combination of I and j. So the first vector is u. Now when it says write a vector in this linear combination of I and j, what it wants you to do is write the vector in this format right here. So I need to take my vector u, and the first thing we need to do is write it in component form. So remember, to do that, we take terminal point minus initial, so -1 minus 2, 3 minus a -5. So I've now written u as, in component form, -3, 8. So it's really easy from component form. All we have to do is write -3i plus 8j. And now we've written this vector as a linear combination right here. All right, let's look at the next one, w. I want to write this vector, which will be 2u minus 3v. So what's nice about this linear combination format is you don't have to work in component form anymore. So this vector w, we've already written this vector u here in the previous part as minus 3i plus 8j, and then minus 3, and then v, if you look back in the problem, v was 2i minus j. And so now when you do the scalar multiplication, you just distribute the 2 over to each part. And then distribute the negative 3, so it'll be minus 6i plus 3j. And then you just have to group up the like terms together. So negative 6i, that's going to be a negative 12i, and a positive 16j and a 3j would make 19j. And there's my answer. So working with these standard unit vectors is pretty easy. So we're going to look at another way we can write vectors in these standard forms. So remember that a vector has two parts to it, right? It's got a length and it's got a direction. And another way you can think about direction is the phrase angle. You can think about direction as being angle. So let's say I start off with a unit vector. And I'm going to assume that its initial point is at the origin. So here's my unit vector, u. Well, because this is a unit vector, I know that length of that vector is 1. So this vector must touch the unit circle. But I know on the unit circle, the points on the unit circle correspond to this angle theta, and the point would be cosine theta, sine theta. So this vector u in component form would be cosine theta, sine theta, or if you want to work with the standard unit vectors, it would be cosine theta I plus sine theta j. Okay. Well, what if my vector is not a unit vector? Well, you can still have something very similar. So if v is a non-zero vector, it has to be non-zero, then the vector v, it's the magnitude of v times this vector. Or again, if you want to work with this in standard unit vectors, be this plus the length of v sine theta j. So there's another way you could view your vector. So let's look at an example related to this real fast. Example. Let's suppose I tell you that v has a magnitude of 3 and the angle of 30 degrees, which is the same thing as pi over 6 with the positive x-axis. Well, we can write v, right? Our formula up there that I have underlined says this is how we can write the vector v. And I know the length, they tell me it's 3. And then cosine, we're going to work not in degrees but radians, so cosine of pi over 6I plus 3 sine pi over 6j. So if you plug these in, we can now write the vector v as 3 square roots of 3 over 2I plus 3/2 j. So if you know the magnitude of your vector and your angle, you can write the vector explicitly.